Hi everyone, my name is Deeks. I'm the CEO of CodeStrap, which I founded with my very good friend who is in the room, Dorian Smiley, the original CodeStrap himself, famous in the developer community, and has a brilliant YouTube channel that we now get to use. At CodeStrap, we help our clients become mission-driven, master the Foundry platform, and avoid foot-gunning themselves and other pitfalls that they might experience when trying to use technology as an enabler. So let's dive right in and double-click on AI, particularly the second word in that acronym, intelligence. Large language models exhibit intelligent-like behavior, but they certainly lack human levels of intelligence. And in our opinion, there are three observations that define that intelligence deficit that essentially makes them non-viable for human replacement. I'll put a period on the end of that. The first observation is that it's hard to teach them new facts. Well, all right, we're back. Models are pre-trained, and sure, you can do post-training or fine-tuning, but they have weights, not memory. You can't simply tell a model a cheeseburger meal costs $5.99 up from $4.99 once and expect it to retain that information. And in a real world where the facts are changing constantly, it can be incredibly hard to keep up. You have to provide these things hundreds, if not thousands, of examples to get it to give you the right answer of how much does a cheeseburger, fries, and a milkshake cost. The second observation is that it's hard to retrieve or get the models to retrieve facts reliably. These models are non-deterministic, probably the most overused sentence in the human language at this point. Having an employee who occasionally gives you a milkshake when you ask for a cheeseburger or tries to charge you $1,000 when they should charge you $5 is by definition an unemployable person. And we should expect the same from our technology solutions, or the quality should be the same. The third is that it's hard to know if the answer that they give us is correct. If you have a fallible system, which observation 1 and 2 clearly point out, you need to understand how it reached the conclusion so you can determine if it was right or wrong. LLMs, if everyone in the room knows, operate from or replicating patterns from vast data sets. A process that can mimic reasoning, it looks like it's getting to the right answer, but they don't really have a real-world interpretation and a model, meaning they don't know when they're right or wrong, which can obviously confuse us. Simply put, every output from an AI system is gonna have some errors. And we should have extreme skepticism and take a stance of zero trust when using these tools. And if we don't start treating them from a stance of zero trust, we're gonna keep getting headlines like this. Some are hilarious. If you haven't heard about the McDonald's drive-through lines and their implementation of AI, you absolutely should. We have airlines who are issuing fictitious offers and pissing customers off. Sorry, Deloitte, I included you in this. Hallucinations in deliverables that get you sued. We have code bases being deleted from teams that are using vibe coding platforms that then the CEOs of those vibe coding companies have to go on X and apologize. And of course, we have the famous MIT report that says we're all failing. I say all that because currently on a global basis in software development, we're generating an absolute perfect storm here. Very recent research that pissed off the company it was about came out that when we look at the output from these AI systems, we're currently still getting about 30 to 90% unsubstantiated outcome. What does unsubstantiated mean? Inaccurate, wrong, made up. At the same time, we have developers at a near ubiquitous level, 95%, who are relying on AI to perform their workload. 80% believe that it's making them more productive. And 70%, based on the recent DORA report, reported that they somewhat to a great deal trust the output. So we have a complete disconnect here. If the system produces poor quality, we believe the opposite to be true, and we adopt at near ubiquitous levels. Rest assured, we're going down a dark road indeed, And again, I'll point back to that MIT report that shows basically if we try and keep doing this, we're just going to keep getting about 90 to 95% failure. There are success stories, though. Meet your neighbors, talk to people at this conference. I'm so excited that we actually have this conference now. Me and John were talking about it years ago at AIPCon, which is very exclusive. Hopefully we can grow this to be much bigger. But this is where success is actually happening. We could not agree more with the recent Dora report. Please go read it. In that the greatest returns from large language models will come from those that invest in foundational systems. That's your internal platform, wink, wink, your data ecosystem, and your core engineering disciplines. Palantir Foundry obviously covers all three. The platform is very opinionated in how you construct solutions. That covers the third bullet there. These are essential prerequisites turning AI's potential into measurable organizational performance improvements, which should be the goal of everyone here, right? Not just building toys. We're going to show you in a minute our augmentation of that. That'll basically add fuel to the fire for anyone using Foundry. The teams that are winning today deeply recognize the fact that AI is an amplifier, realizing that it's going to amplify the good and it's going to really amplify the bad. And knowing that, we must do everything in our power to reorient ourselves on the concept of amplification. And when we do that, intelligence augmentation, not autonomous artificial intelligence, really comes into focus. So that's what we set about as a mission. So accounting for our three truths of LLMs, we took a novel approach focused on intelligence augmentation. First one, hard to teach new facts. Well, rather than try to teach them new facts, we simply use LLMs to extract features from unstructured data, which is leaning into their strength, by the way. And that's it. Addition through subtraction, guys. We don't need to teach them new facts. We give them the facts, and they extract the key features we're interested in. To address fact retrieval reliability, we provide an interface for the model to retrieve facts from what essentially is long-term memory. We do this through LLMification of our code base and relevant documents to provide the model and the developer what is essentially a Rosetta Stone of the development process. In layman's terms, for the non-technical folks in the audience, this involves saving information about the model's actions and the generated outputs. If you want to know more about how we did this, number one, we're heavily posting on all social media to show you guys how we do it, but also Dorian Smiley's here so that he can walk through anyone that wants to deep dive the capability. But you can think of it like memory and a structure that provides traceability, retrievability, and therefore reliability. And then to ensure the answer is actually correct, we focused heavily on generating evidence through the whole software development process, automated reasoning checks, and opinionated points where the human developer has to be involved, non-negotiable, never going to change. In addition to complete auditability, we dramatically reduced the surface area for potential non-determinism, and then dramatically heightened human cultivation, right? Intelligence augmentation means we have to improve our human capability. All right, back to Palantir. We're at a Palantir conference. Any intelligence augmentation strategy, whether it's ours at CodeStrap or whether you generate one or a different company helps you with that, is going to still struggle with these three challenges: model grounding, security, and value. We chose Palantir because it's a categorical solution to these challenges for any company. The first is model grounding. Well, with Foundry, we can bring in all the data into the same decision-making process, or the loop, that we humans have to get high-quality answers to high-value questions. For the life of me, I don't know why we ever thought that AI was just going to be able to know all this stuff we know. I think we're all over that fact of it being an oracle. But here with the platform, we can ground the model in all the data that we use. The second is we get security out of the box, that when AI is operating on the human operator's behalf, it has the same scoped permissions as the human operator. It's a really hard problem to solve. Thank you, Palantir, once again, for solving that for us. The third is value. We have a massive competitive advantage around cost in that when we ship our software, Larry or something else, our clients are only paying for the software. They're not paying for infrastructure. They're not paying for an organization to support that, similar to a software as a service company. They're only paying for the value it brings, which again, anyone starting a company that has Foundry gets this advantage. It's absolutely incredible. Okay, so when we were looking at the current offerings for AI coding tools, all of it focused, and if you use these things, it's all focused on AI in the lead, not the human deeply involved, not intelligence augmentation. We believe that's an incredibly flawed strategy, again, going back to our 3 observations. Getting back to first principles, we knew we had to build Larry. We're going to show that to you in a second. But in our methodology, we deliver on these 6 core pillars. Cultivate human capital, non-negotiable, can't let our developers' skill atrophy. That's a mistake. We address the asymmetry between reading and writing code. There's a massive asymmetry there, but again, for the very same reasons, we can't let our skills atrophy. We handle complexity growth and account for the laws of software evolution, which dictates the more code you add, the harder it is to write more code. You can think about everyone vibe coding, massive amounts of code proliferation, complexity growth, We measure outcomes, which improve over time. We're going to show you engineering as ontology. Again, it's something that's fully replicable by anyone who's using Foundry or otherwise. And that allows us to improve over time, right? We can see where we're deficient, where to invest more. When you're augmenting yourself with something like Larry, we want to see exactly where we're getting performance increases, and then, again, where to address deficiencies. We support collaboration across developer teams. I think it's kind of a myth that you're like working in isolation in a basement writing code. You're always involved with teams. You're using existing tools to manage that development process. We need to make sure that we integrate with those tools. And the last one, my favorite as the CEO, is that it's basically free. We've driven the cost out of the system, made sure our tokenomics are essentially so reduced that we can deliver the solution for free. Trying to match that. All right, let's see, Larry. If we can flip to the video. All right, so Larry's our AI assistant, AI coding assistant. Again, it's built entirely around the concept of intelligence augmentation. There's our extension in VS Code. Larry uses Git working trees. I'll pause here for a second, just so that we can run many instances of Larry. It allows us to, focus on one feature and have many instances going at the same time, or work on various different ones at the same time, which is gives us even a bigger efficiency boost. You can launch a new working item, which we're doing right here in the demo. You could also pull up an existing one. And then we have specialized agents that work in specific parts of the code bases or the packages. Here we're choosing Google. That allows us, obviously, to get heightened outputs with that specificity. Okay, so it generated the working tree on the left. You see that. And then it launches a Docker container. The Docker container is where Larry resides, runs. It allows us to, guarantee security, which, again, if you read about what's going on with people using AI, security is something you have to focus on and solve for. It also allows us to be interoperable, such that we can deploy Larry, particularly to Foundry, but it could also deploy to your local workstation or anywhere else. Okay, now we actually want to start building our feature, so we're going to ask for it. What we're asking here, if you can't see, we're asking for a search functionality for Google Docs. Essentially, kind of whatever feature you want to build, you can ask for, as long as it's relevant to the package that you're in. Now, the first thing we do is make sure that we ask questions of the human developer. These questions allow us, one, to cultivate human capital. Like, you asked for something, but have you considered these other things? And we gate that here, you see on the right, and you're able to answer those questions that Larry is proposing to you. We just did this, me and Dorian outside. He's like, let's run another feature. And we asked for something, some type of search feature. And I was like, oh, these questions actually get to the specificity I wanted in that feature. So it gets you to like think about the edge cases, think about the additional things, particularly from a software development perspective, that you might not immediately think of. And it's gating that early on, so you get a better outcome at the end of the day. So developer is clicking through those things. You accept or reject. You've essentially answered those questions and responded back to Larry. Okay, so it's actually generated the spec review now. Or excuse me, it's generated the spec for review on the left-hand side. You see the preview on the right. You have the ability to edit it. Obviously, when you're doing this at this point, you're going to spend much more than the 2-3 minute demo here I'm showing you. You'd review the edits. You'd review the spec and any type of relevant documentation that might be associated with what you're trying to build. Okay, so the spec meets code owner requirements from the template. By the way, we manage those templates. The code owner has to own those things such that when you're getting that heightened output, you're still building from something that a human actually owns. It also generates Gherkin specs. These are your test specifications written in natural language that we're going to hand code later. LLMs are really bad at writing tests. They'll even delete tests and say they didn't. So we need to make sure those things are done by the human operator. All right, let's approve and move to the proposed code edits. Okay, so this is specifying the actual files that it's going to edit. Again, at every stage, we have the human validating that it's doing the right thing. We're actually collecting the data of the development process, which I'll show you in a bit how that gets us to engineering as ontology, where you're creating that auditability and the ability for the next developer who might step into this to actually understand what you did, which is not really addressed by other AI coding tools. Okay, so we see the detailed edits that are going to happen in the specific files on the left. These are down to an atomic level that a human developer can actually understand. When you have these massive vibe-coded change sets, you can't reasonably address those things. So you get down to a digestible amount that a human can understand within the file and the specific edits, and then you're actually able to, once again, edit if you want, or approve the edits that are being proposed. Okay, so there you see approval. You could reject it and then regenerate it. You'd have to explain why. Again, we want to collect data at every stage of the development process. So we've approved everything. Now we're moving on to see how those code edits will be applied. Okay, so we represent those edits through JSON. It's a symbolic approach. Again, go unpack that with Dorian later on. But what it does is allow us to get to the concrete edits. So downstream, we can apply those deterministically. We're not allowing LLMs to apply those edits. This approach is one of the core reasons why we're able to drive the cost down so low. We generate far less tokens with this method than others. Okay, so our edits have been applied. It's time to review those changes. Here we see those. Again, you can see all the potential edits, the diff views. And then at this point, right, you're actually reviewing, trying to reduce entropy. You have to hand code the tests such that the code actually generates something that you want. That, again, allows for human cultivation. The developer's skills are actually being improved, and they're not atrophying, which is pretty sweet. I'll take Q&A at the end, by the way, and then again, Dorian's in the room later on once, or if you have questions. Can we flip back to the slides? Okay, so earlier there were some question marks underneath Palantir's logo. That question mark is Larry. The thing to never forget here is that technology solutions, whether it's Larry, whether it's Palantir's, is that we're enabling a business outcome, meaning value is actually being accrued. And by not forgetting that, and again, having that be one of our core principles, right, in those 6 I showed you, we always have to then track the value. How do we do that? We track performance through engineering as ontology. We can show you this later too, but because you're pretty far away. But essentially, we have DORA metrics, outcomes of engineering, not output, not lines of code or tickets addressed. This is actual things that then provide us a feedback loop to improve outcomes over time. Well, when we go and work with a client with Larry, that allows us to continue to invest in generating better and better outcomes. And that creates not just the capability, but also being able to track the outcome. That allows us to generate an extreme asymmetric advantage for our customers, because we can prove that we're actually getting better and making them better and driving better outcomes. It also generates extreme asymmetric advantage for our shareholders, because we're constantly looking at ourselves in the mirror, how we're developing both Larry and our internal capabilities, and improving where we're deficient, and then leaning into where we're having high success. So that's Larry, our AI-assisted programming capability, and obviously engineering as ontology. Again, it just makes us laser focused on intelligence augmentation, and then again, getting back to those, the fallibility of LLMs, address those. So where are we all going with this? Well, let's talk about that. LLMs are great at using language, as are we all. And if we design for language and focus on intelligence augmentation, there's a pot of gold at the end of the rainbow. We're not the only ones saying this, by the way. If you look at what OpenAI, ChatGPT is going through, this is interaction through language, exposing other tools and capabilities from other companies. AI FDE is similar, natural language, using the primitives underneath the hood of Foundry. And when we boil it down, what is the most powerful form of intelligence augmentation? Well, that'd be an entire system built by and for language. Language as the inputs, language as the outputs. And if I make a parallel to science fiction and take everybody's favorite Marvel superhero, Tony Stark and Jarvis exclusively talked through language. They weren't sending emails to each other as they're flying around in the air. And Tony Stark was one man that could fight an entire army, right? But if you think about the superpower he had, it was more about the silicon in Jarvis than it was about the iron. And I don't know about you guys and gals, but I want Jarvis in every type of business function that I have to do. With a focus on language, we get to a world where we're all interacting with software, and software is interacting with each other through language. This will reduce the friction in the vast array of software tools that we all use today, and again, get closer to a bevy of Jarvises. We can wipe away clean that friction that we all experience with trying to, remember every single interface of every SaaS product and every website and all of that. And frankly, that, whether you realize it or not, and you actually look at some studies about this, causes a lot of stress. It's obvious the lost time and the context switching. And then we have just a huge amount of poor decisions. If we get to this language future, this will obviously lead to faster decisions, better outcomes, compounding returns, and it'll be a lot more human in the future, right? Interacting with computers has kind of degraded the human experience, I'd say. This would get us back to a better state. What's the fastest path to realizing this capability? Well, that's what we're doing. We're using Larry, buoyed by Foundry, to build the natural language interface for the web as quickly as possible. And that web is obviously composed of the API economy. Why? Well, whether you're sending an email, using ClickOps and Foundry, interacting with S4HANA or Salesforce or Coupa or insert your system here, you're actually interacting with the API economy. And by wrapping enough of that API economy first, and having the fastest mechanics to do so with Larry, particularly when we get to clients who may have bespoke needs, we can offer another unique competitive advantage. At the end of the day, a natural language interface is the logical conclusion when you think from first principles and understand AI's primary role is that of an amplifier. Okay, so love for you guys to build with us, schedule meetings with us, talk to us today. Again, Dorian is in the audience. He can do a deep dive later if you want to. But I'm happy to field some questions with the remaining time.